Hello everyone. Today we are going to discuss about the introduction to probability in machine learning. So let me start with the basic one. What is probability? So probability forms the backbone of many machine learning algorithms, especially when dealing with uncertainty, predictions and decision makings. So it's a mathematical language of uncertainty and it tells us how likely an event occurs with values ranging from 0 to 1. So this thing, probability is about predictions of uncertainty. So it's like non-predictable situations are being predicted by using the method of probability, like tossing of a coin. Okay. So let's define a few terms like the sample space is the set of all possible outcomes. An event is any subset of outcome. The probability of an event measures how likely it is to happen and etc. So now let me move on to the basics of probability. It helps with quantifying uncertainty, modeling random processes, making predictions with confidence, and from naive Bayes to Bayesian networks, probability plays a huge role. And the two important rules in probability are addition rule and multiplication rule. And when it comes to the methods, the theoretical probability, empirical probability, and subjective probability are the three main methods. So, theoretical probability is based upon mathematical reasoning, where the probability of rolling a 4 on a fair die is 1 by 6, and empirical probability is based on experiments or data. Let's say we have a coin that tossing of 1,000 times and 496 of them are heads, and the empirical probability of heads is 496 by 1,000. So this is an example. And when it comes to subjective probability, it's based upon personal belief. A doctor might say there's an 80% chance of treatment will work based upon his experience. So this is how it works, subjective probability works. And when it comes to the applications, naive Bayes classifiers, Bayesian networks, hidden Markov models, Gaussian mixture models, and Bayesian neural networks. So probability concepts are widely used in this machine learning with of these various models of machine learning. Naive Bayes is the simple feature relationship. Bayesian network is about model dependency between two variables, and hidden Markov models is for sequential data like speech, text, and etc. Gaussian mixture model is for clustering of data points, and Bayesian neural networks is to introduce uncertainty in deep learning networks. So, to deepen our understanding, let's view the notebook where we will explore these concepts deeply with practical coding examples. Yes. So, as I said you before, the probability is a branch of mathematics that deals with uncertainty, and machine learning is full of uncertainty. So, this probability helps us to make predictions, classifying data, and reason about the world using models that aren't perfect. So the first thing to say and the key definitions are about sample space. So it is like a set of all possible outcomes. And event is a subset of a sample space. And probability of an event is numbered between 0 to 1. And as I said you before, the basic rules, the addition and the multiplication rule. The probability of A or B is the sum of their individual probabilities in addition rule, and the probability of both A and B are happening. And this comes under multiplication rule, where this multiplication rule acts under conditional probability. So I already said you before of why probability to understand basic concepts, applying the rules like addition, multiplication, conditionality, and etc., and understanding random variables like PDFs and PMFs, and use probability in ML context. So this is how we we can say why probability is used. And here is a small example that shows how to simulate coin tosses. So let's simulate coin tosses of considering the coin is of 1,000 times using Python. The result we get is empirical probability, which means it's based upon actual experiments. So if we keep running this many times, we'll get closer to the theoretical value of 0.5. For example, now we got around 0.496, which is pretty close to 5, right? So this is how the empirical probability works. And when it comes to the random variables of PMF and PDFs, so in probability, a random variable maps outcomes to number. There are two different types, discrete and continuous. So discrete random variables are called as PMF and continuous random variables are called as PDF. So in the first example that you can see above, here is the PMF of a fair six-sided die. Each outcome has probability of 1 out of 6. Okay, so this is an example, and here we can see that a fair die roll where we can see the outcomes of 1, 2, 3, 4, 5, 6. Everything is reaches stop to the 0.16. And when it comes to the second example, which is a continuous example of PDF. Now, in this normal distribution or the bell curve, which you can observe, the most common example of these PDFs, the bell curve is the most common example. This shows a probability density of the continuous values that are centered around zero. Okay, here you can see around zero, right? So now comes the conditional probability. Uh, it's a probability of an event happening by the given. Okay, event happening given that another event has already happened. It tells that the event is happening when the given another event has occurred. So it already happened. So this is how conditional probability works. So I already gave the formula. P of A by B is P of A intersection B by P of B. And when it comes to the Bayes theorem used in naive Bayes, so generally Uh, this is used in naive Bayes classifier, where example in medical diagnosis and spam filtering. So in the code, we can observe the formula where I have given a random numbers and the formula is performed. So the probability in machine learning acts in many models. So, how you might have a question, how does all this connect to machine learning? So, these are the 6 different models that are present in machine learning, which help to build probability more efficient way. We already discussed this before in the PowerPoint presentation. The naive Bayes classifier assumes the independence between features, where it uses the Bayes theorem. Okay, and Bayes networks are a graphical model of conditional probabilities which are explained, and hidden Markov models are used for sequence prediction. It's not a parallel prediction, it's a sequence prediction. And Gaussian mixture model is used for clustering, and the Bayesian neural networks are used to handle uncertainty in deep learning. So in the first one, the naive Bayes, we already know how this works. It takes the data from I taken the data from Iris, okay, the Iris data set. So I have tested it, I have trained it, where you can see the output even though after testing and training, right? So this model assumes the features follow a normal distribution table, a normal distribution, and they are independent. And look, we get high accuracy even with a simple model. That's the beauty of Navy bias. So simply to wrap up, and these all 6 models are important, but not such important. Why? Because in many of the models, some of them fail during the processing of testing and training the model. So I have only given you the naive bias example. Why? Because it works beautifully. So, to wrap up, probability is the language of uncertainty, and machine learning is all about making decisions in uncertain environments. So, we covered the key definitions, probability rules, random variables, conditional probabilities, and Bayes theorem, and how probability powers the real machine learning models. So, by this, we can definitely say that probability in machine learning is so important, where when the machine is properly worked at that time, we can definitely say that probability is working. Why? Because entire machine learning is a model to predict. Thank you.